Physicists say that the universe had its start in an event known as the Big Bang, generally 13.7 billion years ago. This event marks the beginning of all that we know in the universe, an extraordinary explosion that led to all matter, energy, and existence itself. The theory of how things came to be has long been the predominant scientific explanation for the start and evolution of the universe, describing a moment when the universe rapidly expanded from a hot, dense state into the vast universe we observe today. However, while this theory offers a framework for understanding the universe's early development, it leaves many questions unanswered. One of the most captivating questions is what triggered this immense explosion. If the Big Bang was the start of everything, what caused it and why did it occur? These are questions that have fueled the curiosity of scientists for many years, leading to intense study, discussion, and observation in the quest to understand the origins of our universe. Over time, researchers have continued to explore and study both the science and history of our universe. The Big Bang theory has been the most dominant explanation for everything we see, from the distribution of galaxies to the cosmic microwave background radiation, the faint glow of the Big Bang itself. Countless studies have been conducted over the years, with thousands of scientists around the world dedicating their careers to uncovering the mysteries of the universe. The data gathered from these studies has consistently supported the theory of how things came to be as the leading model for the evolution of the universe. According to the theory, a mysterious force known as dark energy plays a pivotal role in the ongoing expansion of the universe. Dark energy, which is believed to be far more abundant than the energy found within galaxies, acts as a repulsive force that causes the universe to expand at an accelerating rate, opposing the gravitational forces that would normally pull everything back together. The field of cosmology has advanced significantly over time. As technology progresses and we develop new tools for observation and experimentation, our understanding of the universe continues to evolve, and many things we once accepted as absolute truths have been shown to be incomplete or even entirely wrong. As new evidence becomes available, a prominent figure in modern theoretical physics, Michio Kaku, has pointed out that even the theory of the universe's origins, long considered the foundation of cosmology, is now facing challenges. Recently, observations made by the James Webb Space Telescope have sparked significant debate among scientists. The telescope has identified 750 new galaxies that appear vastly different from what was previously predicted based on past models. These startling discoveries are compelling researchers to reconsider established theories and delve deeper into the mysteries of the universe. As these revelations unfold, they hold the potential to reshape our understanding of the cosmos. The James Webb Space Telescope, with its cutting-edge technology, is changing the way we view the universe. The findings it has made so far have pushed the boundaries of our knowledge, particularly regarding the formation and development of galaxies. The telescope has captured images of many galaxies that challenge previous assumptions, leading to a new perspective on the universe's evolution. These discoveries are exciting not only because of what they reveal, but also because they challenge long-held beliefs about the Big Bang. For those eager to stay informed about the latest advances in astronomy and cosmology, the images and data coming from the James Webb Space Telescope offer a fascinating glimpse into the farthest reaches of space. The newly discovered galaxies, with their stunning structures and astounding numbers, are prompting researchers to revisit their theories and explore new possibilities regarding the universe's beginnings. The James Webb Space Telescope has delivered some of the most breathtaking images of galaxies ever captured. In a single image, one can see countless galaxies grouped together, their beauty and enormity surprising to the average person. However, for professionals and experts, these images are not just visually striking, they are also profoundly astonishing. The galaxies captured by the telescope are vastly different from what scientists had expected based on the Big Bang model. They appear smaller, more diverse, and surprisingly old, raising questions about the accuracy of existing cosmological theories. These surprising observations are generating waves of concern within the scientific community, with some analysts even using the word panic to describe the reactions to these new findings. The discrepancies between what was previously expected and what has been observed are driving scientists to re-examine the fundamental assumptions of the Big Bang theory. For years, the theory of how things came to be has served as the primary explanation for the origins of the universe. According to this theory, Approximately 13.7 billion years ago, the universe began as a single, unimaginably hot, dense point that rapidly expanded in what is commonly referred to as the Big Bang. This explosive event set into motion the evolution of the universe, ultimately leading to the formation of galaxies, stars, and planets, including our own. However, the new images captured by the James Webb Space Telescope have cast doubt on this long-accepted story. These images challenge the established narrative of the universe's beginning and have opened the door to further possibilities regarding how the universe came to be. The galaxies revealed in these images appear to be too small, smooth, old, and very young to fit within the framework of the Big Bang theory, suggesting that the true story of the universe's origins might be far more complex than previously thought. One of the most striking aspects of the universe as seen by the James Webb Space Telescope is the size of these galaxies. These galaxies are several times smaller than those captured by the Hubble Space Telescope, which directly contradicts the assumptions of the Big Bang theory. According to this theory, as the universe expands, objects within it should appear larger as the distance between them increases. However, the galaxies observed by the James Webb Telescope are not behaving as expected. They are smaller and more compact, defying the standard model of cosmic evolution. Additionally, the smoothness of these galaxies is a surprising and puzzling feature. The Big Bang theory predicts that galaxies should show a significant degree of irregularity in their shapes, with noticeable variations due to the tumultuous processes of their formation and evolution. However, these new galaxies are remarkably smooth, with far less complexity than scientists would expect for galaxies of their age. This smoothness challenges the timeline of galaxy development and suggests that something about the standard model may need to be rethought. At the beginning of the universe, all matter, energy, and the building blocks of the universe were packed into a single point of unimaginable density known as a singularity. This singularity represents the starting point of everything, where the laws of physics as we understand them begin to break down. In this state, matter and energy were so densely packed that their behavior becomes difficult to describe using conventional physics. The nature of the singularity is rooted in Albert Einstein's theory of general relativity, which explains how gravity acts on massive objects within it. The density of matter reached an infinitely high value, creating conditions that we cannot fully comprehend or replicate with our current understanding of physics. The temperature at this time was extreme, far exceeding anything observable in the universe today. It is within this singularity that the seeds of the universe were planted, with all the mass and energy needed to create everything we see around us today. After the initial singularity, the universe began to expand and swell, going through a rapid process that stretched the fabric of space itself. This expansion, known as cosmic inflation, occurred at an incredible rate, far exceeding the speed of light. During this phase, the universe expanded drastically, smoothing out any irregularities and laying the foundation for the large-scale structures that would later form, such as galaxies and stars. Cosmic inflation played a crucial role in shaping the universe as we know it today. It homogenized the distribution of matter and energy, ensuring that the universe would be relatively uniform on a large scale. As the universe continued to expand, the rate of expansion gradually slowed, leading to the development of more complex structures. Scientists have been able to observe the effects of this ongoing expansion through phenomena like the redshift of light from distant galaxies, which shows how the universe continues to grow and evolve over time. During the early stages of the universe's development, all matter was compressed into a small volume, creating conditions that would have made it impossible for stable matter to exist in its current form. However, as the universe expanded and cooled, these extreme conditions began to change, allowing particles like protons, neutrons, and electrons to form. These particles interacted with the surrounding light and energy, eventually leading to the creation of matter as we know it. This process, known as nucleosynthesis, occurred during the first few minutes after the Big Bang and played a critical role in the creation of the elements that make up our universe. Interestingly, while scientists expected to see chaotic and disturbed galaxies due to various impacts during this early period, the images captured by the James Webb Space Telescope tell a different story. Instead of observing tumultuous galaxies, the telescope has revealed well-organized spiral and elliptical patterns that resemble the galaxies we see in the universe today. This challenges the idea that collisions and impacts were common in the early universe. The optical illusion predicted by the expanding universe theory, in which objects should appear smaller due to cosmic expansion, also fails to hold up against these powerful observations. The galaxies captured by the James Webb Telescope do not appear minuscule, raising further questions about the validity of the Big Bang theory. Additionally, the age and abundance of these galaxies challenge the idea that the universe followed a predictable path of development and evolution. The telescope's infrared capabilities allow it to focus on the light from distant galaxies, providing insights into the ages of stars and galaxies. This has led to the discovery that many of these newly found galaxies are much older than scientists had anticipated, further complicating the narrative of cosmic history. As we continue to learn more from the James Webb Space Telescope, it becomes increasingly clear that our understanding of the universe may need to be revised. The potential implications of the telescope's discoveries extend beyond re-examining the Big Bang theory. One significant aspect of the findings is the possibility of uncovering new aspects of physics that could help us better understand the universe. By identifying structures that don't fit into the traditional cosmological model, researchers are being pushed to reconsider how we conceptualize the fundamental forces of nature and the ways in which galaxies and stars evolve. This reassessment could lead to the discovery of new physical principles that govern the universe, as well as the potential to develop alternative theories for how the universe began. While it remains uncertain how this new information will affect our understanding of cosmology, it is clear that the field of space science is undergoing a major shift. The future of astronomy and physics is bound to be filled with exciting revelations and questions that could redefine our place in the universe. We are only beginning to scratch the surface of the wonders of the universe, and with each new discovery, the possibilities seem limitless. The future of space exploration holds tremendous potential, and with the continued advancement of technology, we may be on the verge of uncovering new truths about the cosmos and its origins. The James Webb Space Telescope is a powerful tool that promises to guide us on this journey, opening up new frontiers and revealing the secrets of the universe that have long eluded us. Ultimately, the new findings from the James Webb Space Telescope offer hope for a deeper understanding of our universe. They may hold the keys to answering fundamental questions about the cosmos, such as its origins, its ultimate fate, and the nature of the forces that shape it. As these discoveries continue to unfold, we can expect more revelations that could challenge long-held beliefs and provide exciting new avenues for exploration. With each breakthrough, we move one step closer to unraveling the mysteries of the universe. The revelations made by the James Webb Space Telescope are not only reshaping our understanding of the universe, but they are also sparking discussions that could change the very foundation of cosmology. One of the most profound aspects of the telescope's findings is how it challenges the assumptions made about the early universe. The galaxies identified by the telescope are suggesting that our understanding of cosmic evolution is incomplete, perhaps even fundamentally flawed. These new discoveries raise questions about the process of galaxy formation. For instance, previous models based on the Big Bang theory emphasized a gradual evolution of galaxies from smaller, irregular forms to larger, more organized structures. However, Webb's data reveals galaxies that appear to have formed much earlier and more rapidly than expected. Some of these galaxies are remarkably mature, with organized structures like spirals or ellipticals, even though they are purportedly very young. This observation forces scientists to reconsider the traditional view that galaxies grow through slow and continuous processes of mergers and accretion. Furthermore, the newfound diversity of these early galaxies challenges the idea that galaxies should evolve in a uniform manner. Rather than showing a gradual transition from chaotic to orderly, many of the galaxies discovered by Webb appear to be well-developed from the outset. This surprises researchers, as it contradicts predictions made by standard cosmological models, which suggest that early galaxies should have been more irregular and turbulent, driven by violent interactions in their infancy. The sudden appearance of these mature galaxies also raises questions about the timescale of cosmic evolution. If these galaxies were able to form so quickly, it suggests that the universe may have evolved at a much faster rate in the first few billion years than previously thought. This rapid formation of complex structures could mean that the entire timeline of the universe's growth, as outlined by the Big Bang model, needs to be recalibrated. The old assumption that the universe took billions of years to reach its current state may need to be reconsidered, or at least refined. Additionally, These observations of early galaxies reveal a surprising level of uniformity in their properties, even though they are separated by vast distances. This level of consistency across different regions of the universe further complicates the idea that the universe's formation was a purely random process. It also raises the possibility that there are underlying factors or principles at play that we are only beginning to understand. Some researchers have even speculated that these findings could point to the existence of unknown forces or phenomena that could have influenced the formation of these galaxies. While it remains unclear how these discoveries will ultimately impact our understanding of the cosmos, one thing is certain. The work done by the James Webb Space Telescope is a monumental step forward in our quest to unlock the secrets of the universe. As data continues to be analyzed and new discoveries are made, the scientific community will likely have to reconsider much of what we thought we knew about the history and evolution of the universe. These revelations are opening up new avenues of research and could lead to groundbreaking shifts in our understanding of cosmology, perhaps even prompting entirely new theories to explain the cosmos. The future of astronomy has never been more exciting.